Okay, so let's get started for the day. And a couple of announcements. First of all, I think few of you missed the data camp course that was due yesterday, so I'll send a specific email to whoever missed it. Make sure that you complete it as soon as possible. And also, we're going to do lab 1 today, and it's going to be due 1 week from today. And also, when you get the chance, please form the project team as soon as you can. We already have a couple going on, which is good. And what we're going to do is we're going to keep populating the particular Google Doc that I shared. So we're going to have a separate tab for a particular group, and then we're going to go from there. So make sure that you reach out to whoever you want to work with, and let me know when you form a team, and then we can start the conversation. Last time we were here, if you remember, well, it's probably not on any of the slides, but we're trying to derive the posterior distribution of the P, which is the proportion. So last time we looked at, well, I think I wrote a couple of starting points for you. So let me just do that again quickly, and then hopefully we can come to the derivation quickly. So we have the prior distribution, if you remember. That is a beta. So P is a beta, AB. And we know that that means the prior density, or beta distribution again is a continuous distribution. So we talk about PDF. So P, prior P, is 1 over the beta function, AB, and then P to the power of A minus 1, and then 1 minus P to the power of P minus 1. So that's for the density for the prior. And then for the likelihood, we know that it's a polynomial. And in particular, we write it in terms of the unknown parameter. So we have n choose y, p to the power of y, and then 1 minus p to the power of n minus y. So I was saying, okay, so earlier we threw away those constants, the choose function as well as the beta function, because we know that it goes into the proportional sign, right? But today, we're going to continue the derivation of showing the posterior is indeed a beta by keeping those constants, and then recognizing that the final form is actually indeed the posterior beta that we're looking for. So what we need to do is to set up the base rule for what we do for a continuous case. So remember, for continuous, the numerator will still just be the prior multiplied with the likelihood. The denominator, because it's continuous, so you don't do summation, you do integration. So we're integrating the product of the prior and the likelihood with respect to P. Okay? And what we were left with last time is we can start writing those terms here. So I'm just going to repeat this here. 1 over BAB to the power of A minus 1, 1 minus B, B minus 1, and then the choose function A choose Y, BY, and then 1 minus P, N minus Y. Okay? The denominator is almost the same, except that we're integrating with respect to P here. So we're going to have the integration sign. AB, minus 1, and then dp. So immediately we can see that some of the constants can be canceled out. So this is again different from what we did earlier. In the earlier, when we were using proportional sign, only caring about the numerator, we threw away those constants because they can go into the proportional sign. Right now, is we actually keep them, but because they in the numerator and the denominator, both of them are here, so we can cancel them out. So in the end, we have this P to the power of A plus Y minus 1, and 1 minus P to the power of E plus M minus Y minus 1. In the denominator, we have the same thing, except for the integration sign. dp. Okay. So the goal here is obviously how to figure out what the denominator should be. And last time I was giving you the hint that if we have a beta distribution, we have, let's say, a beta AB, like we had in the prior, E is beta AB, then we know that beta prior is a proper distribution, meaning that if we're integrating the density with respect to P, it's gonna be 1, okay? So that means if we're gonna plug in what we have in terms of the prior, there's integration of 1 over B, AB, then P minus 1 dP. This should be 1, right? That's just like by the property of being a proper distribution. So this is great hint because as you can see, 1 over the beta function AB, it is a constant, right? So if I only care about integration of P, A minus 1, 1 minus P, E minus 1 dP, I simply just move the constant from left to right, and that gives me beta function AB. So this is a given result. It's gonna work for any beta distribution that you have, okay? And this is my hint for you in order to solve what we need to simplify for the denominator here, okay? So in a very similar form, okay? Apparently we need to recognize what that beta function is, which is a constant, and replace that with that based on these integration results. And then once you get that beta constant, hopefully you will see that the posterior is indeed this beta distribution that we derived earlier, which is A plus Y, and then B plus N minus Y, I think, right? Yeah. Yeah, so this is the goal. And this is my hint. And let's spend a couple of minutes so you can work out the detail of simplifying this thing in order to come to this point. Take your time. Okay, I think many of you are getting it now, so let me just cover this quickly. So the hint on the left, that's for any beta distribution, like beta AB. So as soon as you see a form on the denominator here that P raised to some power, and then some power minus 1, I should say, and then 1 minus P raised to some power minus 1, and then you're integrating with respect to P, that gives you the hint that you should use the fact that it's a proper, using the beta distribution. And so what should we recognize this? It should be a B A plus Y, and then B plus M minus Y, right? That will be the function that we can integrate this out. So the denominator will become B A plus Y, B plus M minus Y. So if we keep simplifying this, we get 1 over B A plus Y, B plus M minus Y, and then multiplying with A to the power of A plus Y minus 1. And then 1 minus B to the power of B plus M minus the plus minus Y minus 1. Okay. And once you get to this point, we know that this is a beta density. Okay? So that tells us that E given Y, the posterior, should be a beta distribution with the first shape parameter A plus Y, and then the second shape parameter B plus N minus Y. Okay? Yeah, so this is, I think, the probably the only time that we're going to keep all of the constants and then show that it is indeed a beta distribution. And so now, just to make sure that, well, we can actually just work with the denominator and then going with the proportional sign like we did before. Okay? And for a lot of the models that we're going to cover in this course, you will see that that's what we go for. And then we focus on the product of the prior and the likelihood, and then try to recognize what that distribution is. Okay? So this particular part is just to show you that indeed we can derive the exact posterior distribution. Bayes rule typically is being used in the way that I am highlighting over here, okay? That you care about the non-constants, everything else can go into the proportional sign. Okay? Yeah, so that's for this section of updating beta prior. And what we're gonna that was, I think we covered this, okay.